So today we're going to start our unit on triangles, and we're going to start that unit by talking about how we would classify triangles. And guys, there are two ways in which you can classify. One would be based on the sides of the triangle, and the other would be based on the angles themselves. So let's first talk about the sides. We would classify a triangle as scalene if it had no congruent sides. So guys, this is where you would have to be able to prove algebraically or be told that the length of the sides. So it's not looking at a triangle and saying, oh, it looks the same, so therefore it's this. It's being able to prove it algebraically. So if no sides are congruent, we would call that triangle scalene. But if you have at least two sides of a triangle that are congruent, we would call him isosceles. And then if all three sides are congruent, he would be equilateral. So in speaking of the sides, we can translate that into angles. If all three angles are acute, we would call that triangle acute. If it has, and remind yourself, acute means less than 90. Obtuse, if it has one obtuse angle, which would be one angle greater than 90, then the entire triangle is called obtuse. If it has one angle, which is a right angle, of 90 degrees, we would call him a right triangle. And then if all three angles are congruent, so guys, remind yourself, all three angles in a triangle add up to be 180. So therefore, if they're all congruent, then they would have to be 60 degrees. And then we would call him equal angular. So notice we have an equilateral where all three sides are the same, and we have an equal angular where all three angles are the same. Excuse me. So that's how you would classify triangles based on its sides or angles. Next, we have just some fun facts about triangles. So we have the sum of all three angles in a triangle is 180, which is what we just discussed here, considering that all three would have to be 60 degrees. Acute angles of a right angle are complementary. Okay, guys, that's very wordy. So let's talk about what a right triangle is. A right triangle is when one angle in the triangle is 90 degrees. So if they're 90 degrees, then we only have 90 degrees left in the entire triangle. So therefore, the other two angles would have to be added to give you 90. That's why they're called complementary. Complementary comes from a couple of units back, meaning two angles whose sum is equal to 90. The measure of an angle of an equal angular is 60 degrees, which is what we just discussed right here. And then this is something very interesting. If you can prove that a triangle is an equilateral triangle, which means all three sides are the same, then you can also prove that all three angles are the same. And then that goes the opposite way as well. If all three angles are the same, then that proves that all three sides are the same. We also have something called the exterior angle theorem. We're going to talk about this on Friday. This will be in the next section, maybe not Friday, but so our first unit, our first homework is going to cover sides and angles and a little bit of the notes from 4-2. And then your second homework will talk about exterior angle theorem. This says the measure of the exterior angle of a triangle is equal to the sum of the two remotes. Interiors. So let's get a picture for that. I'm a big visual learner. So an exterior angle of a triangle. So we're talking about this guy out here on the outside of the triangle. His sum, he is equal to the sum of the two remote. So guys, if I covered this up and we talked about just angle 3 and 4, do you see that angle 3 and 4 form a linear pair? So therefore, we're not talking about the angle that is directly beside him, that's adjacent to him. We're talking about the two angles that are furthest away. So angle 4 would be equal to the sum of angle 1 plus angle 2. We call those angles remote. And then the last piece of information for the start of our unit would be the third angles theorem. So it says, if two angles of one triangle are congruent to two angles of another, then we know the third pair of the angles must be congruent. All right, so let's put a picture with all of those words. So what this is saying is, do you see how this triangle has one congruent mark and this triangle has one congruent mark? So you would be given two triangles, and they would both have one congruent mark for an angle, and they would both have two congruent marks for an angle, meaning this angle is congruent to this angle. So if you're told in two triangles that they have two congruent angles, then guys, we can automatically know that the third angle of both triangles would be congruent. So I'm going to give you a few examples based on what the notes that we just talked about. So for example, if you're given an isosceles triangle, now we know that this triangle is an isosceles because it gives us congruent marks on both sides of the triangle, and then it gives us expressions for the measures 5x minus 6 and 3x plus 2. So if this is a isosceles and they are congruent, we can set them equal to each other, solving for x, taking that amount, plugging it in, and finding that each side is 14. That's if you have isosceles, two sides are congruent. So what if you have three sides? So number 2, given an equilateral triangle, all three sides are congruent, but remember, equilateral also means equal angular, which means each angle is 60 degrees. Therefore, we can take this expression of 7x minus 3 and set it equal to 60, solving for x to be 9. Given a right triangle, so notice we call him a right triangle because he has one angle that is 90 degrees. Therefore, the other two angles must add to be 90 because all three angles in a triangle equal 180. Now, I took these two angles, 4x plus 5 and 7x minus 3, and set them equal to 90. Some students like to take these two, add them together, plus 90, and set it equal to 180. That would be perfectly fine because the very first step would get us right down to this. 11x plus 2 equals 90. Therefore, x is 8. And in this one, we plugged it in to get the measure of angle A was 37, measure of angle C was 53, which if you add those together would give you 90. Always check your work. And then I gave a couple of examples of the third angle theorem. If two angles of a triangle are congruent to two angles of another triangle, then the third angles are congruent. So therefore 7x plus 4 is equal to 9x minus 18. X is 11, so if you plug it in, each angle measure would be 81 degrees. Now guys, the example number 5 is the exact same thing, except we're dealing with a quadratic. So we would move the 4x over, giving negative 2x squared equals negative 32. Divide by negative 2 and take the square root of 16. So this will cover the first 2 lessons in the start of our triangle unit. Okay, so the next lesson we will go into how to prove the sides and how to build on our triangles from there.